Right, good afternoon, everyone. Thank you for coming. I'll let the last few come in, and then I'll get started. Right. Hi, my name is Dale. I'm a developer for IBM. I spend most of my time working with Kafka. So I wanted an excuse to talk about Kafka that wasn't too dry and too corporate and too enterprisey. Before I get started, I just want to check some of my assumptions with you. So I'm assuming that you're all either Java developers or you won't be too offended if I spend time pointing at Java code. All okay with that? I'm seeing nods. Good. Tick. I'm assuming you've probably heard of Kafka. Maybe you're not a Kafka expert, but you've heard of publish, subscribe. You know what a topic is. You're okay with the idea of applications putting messages on a topic and getting messages from a topic, yeah? Good. And I'm assuming you're okay if I witter on about video games for the next... I mean, it was in the title, so like, if you didn't want that, you came to the wrong talk. Because I am a bit of a gaming nerd. I have been for a while. This is a photo from a blog post I wrote a few months ago about what I'm playing at the moment. In fact, it's already out of date, because last week I got this, which you won't be able to see from where you're sat, but it's a Star Wars-themed Tamagotchi. So I've got R2-D2 beeping at me constantly. Hopefully it won't come up on the mic. My Switch there. Is there anyone else in the room who's stupidly excited about Zelda? Only a few. That's so disappointing. Well, I'm going to get nothing done after tomorrow. Probably the one that surprises most people is this one. Who's heard of the Playdate before? Only a few. This thing is awesome. It's black and white screen. The controller is a crank. It's the most ridiculous, but the most fun and quirky and creative games console I've owned in ages. This lives in my pocket. This goes with me everywhere. But anyway, this isn't meant to be a talk about my favorite games. The idea for the talk is I wanted to talk about some aspects of doing event streaming, event processing, stream processing kind of stuff. But like I said at the start, instead of doing it in the abstract or with some fictional corporate use case, I'd theme it around video games. So let me start by talking about what I mean when I talk about stream processing, event processing sort of stuff. It's all built around the idea of event backbone. This is your event distribution layer, somewhere where applications can put messages, send messages, and receive them from. So as you're building out your overall architecture, your overall solution, there are four main bits that you tend to have. You need a source of events, something that's going to be emitting events. You need to do something with those events, because otherwise, why are you bothering to put them onto an event backbone? So some sort of stream processing that's going to count them, aggregate them, filter them, analyze them, do something with them. You probably need to put the older events somewhere safe, so you might need some sort of archive. And you probably want to do some sort of notifications. When something interesting happens, you want to trigger an automation or trigger a notification to someone. These are kind of the bits when you're assembling an event streaming application of what you have. And this is a very abstract sort of point of view, but as I said at the start, I tend to work in Kafka, so I think of this in terms of Kafka. I mean, it's kind of very much becoming a de facto standard for this kind of thing nowadays, but other stream processing technologies are available. But when I hear people talk about Kafka, particularly like introductory level talks, people often just think of Kafka as being the event backbone. They think Kafka is a message broker. They think Kafka is topics, somewhere to host, publish, and subscribe. But that isn't all Kafka is. Kafka includes all of this stuff. What you get out the box when you get Apache Kafka is an ecosystem of tools that includes a way of doing the event sources, connecting in your external sources and getting data in. It includes a way of doing stream processing, a really rich Java API that I'm going to be showing you for writing applications for filtering, aggregating, analyzing your events. It includes a way of archiving off to a store and a way of pushing out notifications. So what I wanted to show you today is, let's take it as read, and that's why I asked at the start, you're okay with the idea that Kafka has topics and message brokers, and let's look at all the bits around the outside that comes with Kafka that people often don't think about. So, putting it in Kafka terms, like I said, we're going to take this bit as read, producers and consumers, and there's a Kafka cluster. We're going to look at the rest of Kafka. And this is kind of all of Apache Kafka, what you get with it. So I'm going to be, for my talk today, I'm going to spend half of my time talking about getting data from Xbox into Kafka, and then I'm going to look at how we can use Kafka streams to process that. So we need to start with getting the data in the first place. So what Kafka has for this is something called Kafka Connect. It is a Java framework, Java distributed runtime that can host connectors, and it can bring data into your event backbone from a massive range of sources. There's two ways of doing it. I'm not going to talk so much about sync. I mentioned at the start that you might need some way of archiving off your old events to somewhere safe, like an S3 bucket or something. That's the sort of thing that sync connectors are good at, but I'm not really going to be looking at that today. I'm looking at source connectors. How do you get data into your Kafka cluster? So there's three main bits to running a connector. There's the connector itself, something that knows how to connect to the external system and get data. Transforms, you can do some like redacting, changing, filtering, reshaping of the events that you get from the external system, and convert it, where you basically choose what format you want. Do you want it to be JSON, XML, Avro, protobuf, whatever? And there are tons of connectors available. I didn't try and count them, but we're talking hundreds. So you probably don't need to write your own connector, although that's what I'm going to be showing you how to do because it's more fun that way. There is probably a connector out there for whatever system you're interested in. So, for example, if there's other message brokers you want to bridge and get the data into Kafka, like an MQTT or something, there's connectors for that. If it's a database, every time something changes in a database, you want to capture that and surface it as an event on a topic, change data capture sort of thing. Pretty much every flavor of database, there's a connector, and so on. And for a lot of web services as well, if you want to surface them, SAP, Salesforce, whatever, you can do that. But it's no fun using someone else's connector. Writing your own is clearly the way to go. So for the purposes of this talk, I wrote an Xbox connector, something that's going to get data from Xbox Live and surface it on a Kafka topic. And I'm going to walk you through how I built it and try to not spend too much time on the video game side and more about the how do you write a connector, how do they work, what can they do. So at a high level, what I want to be able to do is get events from Xbox. Actually, I should have asked. Everyone's familiar with Xbox when I talk about Xbox Live. So if I say achievements, the fact that Xbox comes with its sort of social network, so I can see what my friends are playing if I've friended them, that sort of thing. Good. OK. So those are the kinds of things I want to get onto Kafka topics. When someone earns an achievement, message on a Kafka topic. When someone starts playing a new game, message on a Kafka topic. So what I have is so everything I'm showing you is vanilla Apache Kafka, but Apache Kafka doesn't come with a UI. So I'm using IBM offers Kafka, and we have a UI for it. This isn't meant to be a sales pitch. It's just it gives me something slightly prettier to look at, that's all. So this is my Xbox achievements topic, and this is an achievement I earned last night on Burnout Paradise. Try not to judge me for my sleeping patterns, especially considering I had to get up at 5 to get the train in this morning. You can use a command line to read these. So this is the Kafka console consumer that comes out of the box with Kafka. So this is a friend of mine. He was playing Ghostwire Tokyo. I still haven't tried that. So I've now got this stream of achievements every time one of my friends or me earns an achievement. And I've also got a presence topic. So every time I start or stop playing a game, it emits an event onto a Kafka topic. So this was me on the train in this morning. I play a word game, Wordament, on my phone, but it's part of Microsoft, it's part of Xbox Network, so it shows up as an event there. So you can see I was playing that. That's when I started playing, and that's when I stopped. So I must have been playing that for around about 6 minutes. And I put this screenshot in here because I wanted to make the point that this isn't just IBM UI. So I found an open source Kafka UI and used that for a couple of screenshots, just to keep it not too corporate. But it's the same topic and the same Kafka cluster. And you can see here, I think that was me, actually. It's sad that I recognize my user ID, but that was me playing Doom Eternal. So let's try a live demo. Who can, actually, first I'm going to start listening to that topic. And I was never going to remember the command syntax. So here's one I prepared earlier, right? Can someone think of a game, an Xbox game that's on cloud gaming? This is where I find out how many of you are actually gamers. I don't know that one. How do you spell it?
CHORUS.
Oh, I've not played that, but it looks like it's playable online. So we'll give that a go. And here's where we find out if the DevOps Wi-Fi can cope with streaming gaming. Probably not. I'll kill it quickly before any of them get upset with me. Right, so it's starting to play a game. In this, these are old events because it was streaming from the beginning. So what I'm hoping to see within a minute or so is an event showing that I'm playing chorus. Come on, live demo. Don't do this to me now. So what it's doing is, and I'll show you the code in a sec, it's polling the Xbox service because they don't really have like a webhooks or a streaming way of doing it. So they've got a REST API where I can, hey, there we go, down at the bottom, 11:30. So look, it's real. I'm going to stop this because I don't want to take the mick with the Wi-Fi. Let me start my slides again. And I get an event when I stop playing as well. So you can see here, which way around are those going? So that was Andy playing Fortnite. He plays far too much Fortnite. And then 20 minutes later, probably because he lost, he stopped playing. And that was to remind me to do a live demo. So this is what we're talking about, getting data from Xbox and getting it onto Kafka topics. So how do we do it? So this is, oh no, you can't see it because I'm not showing that screen. One sec. So the API you get is from, it's all Java. It's a Java runtime, and they give you some classes that you need to extend. So org Apache Kafka source connector, you extend that, you subclass that, and that's your starting point. There's not much to do in the connector. You have to identify where your tasks are. I'll talk about tasks in a minute. You define your config, like what are the required values. So I need an API key. But this is just kind of boilerplatey stuff. So this is lifecycle sort of stuff. So as you can see, not much code, and pretty much every connector you write is going to start looking a lot like this. The more interesting bit is the task. But before I dive into that, let me talk a little bit about what I needed to do. Actually, just quickly, I should talk about this. So the main interesting bit that is in the superclass is this poll method. I'm going to get called with that by the Kafka Connect runtime, and what I need to return is a bunch of messages to go onto the Kafka topic. So most of what you're writing when you write a connector is something that can reply to this method call of poll. So with that context, let me show you. So the main thing is, and what I really love about Kafka Connect is, when I don't want to have to do all the work of talking to Kafka, because that would be the same for every connector you write. So Kafka Connect does all the stuff about delivering the messages to Kafka. It does retries, it gets acknowledgements, it can handle the auth, it will batch them, so it does it really efficiently, all the stuff that you don't want to care about that isn't specific to your connector. So Kafka Connect, like I say, is going to call poll on your connector. You then do the bit that's specific to your technology. So for me, Xbox, I make that REST call, fetch all the recent stuff that's going on in Xbox, I get back a response with that, and then I return it to Kafka Connect in what's called a source record, and I'll tell you about that class in a sec. And then Kafka Connect will handle getting it onto the Kafka topic for me, retrying if it needs to, doing, I'm done. I don't need to worry about it. I know Kafka Connect will make that happen. And then compressing it a bit, when it's done that, Kafka Connect will call me again with another poll. And then I go and get the latest data, and then I return it, and it gets put onto the Kafka topic. That's kind of like naive first way of writing a connector. I didn't do it that way because I'm using OpenXBL to do this for free because I'm too tight to pay for API access. And what you get, the API limits you get on a free API key is reasonably so, pretty stingy, because Kafka Connect will call your connector with poll basically as soon as it's finished delivering the messages. So like if the messages are small and there's not many of them, it's going to come back to you asking for more in less than a second. And if I start spamming the OpenXBL API multiple times a second, I will burn through my API usage limit in like 10 minutes. So what I did, and what is reasonably common when you're doing this kind of polling backend, you put some sort of in-memory queue in between. You spin off a worker thread that is just going to periodically fetch data and put it onto there waiting to be delivered, get data, put it in there waiting to be delivered. And then when I get called by Kafka Connect on a poll in a separate thread, it can just take whatever's currently sat on that queue and deliver it. So that can call me as frequently as it likes, multiple times a second, and that's fine. I'm not going to mind. And then I can control how frequently I want to poll the actual API, so I'm in charge. And I think it's not just financial reasons you'd want to do that. Like if you've got a back-end system that you don't want to pummel into the ground, you might want to do this kind of thing to have control over how frequently you're calling that back-end system. So I think there are performance scaling kind of reasons as well as financial motivations for doing this kind of pattern. So let's go back to the code. So what I do is, so this is the source task class, right? The one that's actually doing, that's a screenshot. That's why that's not moving. Hang on. I was confused by why my mouse pointer wasn't moving. So this is the source task. This is the class that's doing all the work. And there's a basic life cycle, the start and stop methods. So in start, I'm starting up what I've called a data monitor class. That's going to do the job of polling at a fixed interval. I'll show you that class in a sec. In fact, let's do that now. So if I go into data monitor, what it's doing is creating a regular old Java timer and scheduling at a fixed rate, and I'm taking the poll interval from the config that I got from Kafka Connect. So that means the person deploying the connector can choose how frequently it's going to poll. And I'm starting two workers, one to fetch the achievements and one to fetch the presence, online, offline status. So that's kind of the job of this. And then what it's doing, so you can see here it's calling, I'm using the Java time to schedule to call this at a constant interval. And when it runs, what it does is, here we go. If I go to presence fetch task is probably the easiest. So this is a timer task. I'm just extending Java util timer task. So it's got a run method, and that run method is going to make an API call, fetch, and I'm using JSON to parse the JSON response I get from the REST API into a Java object, and then I add that to my in-memory queue that I've called cache. So that's all that's doing. I did put a slide at the start. All of this is on GitHub, so if you do want to grab this code and change it and do whatever you want with it, please do. But that's all this task is doing. When it's called run, when the run method is called by the timer, it will make the API call, add whatever it gets back onto the queue, and that is done. And then on the other side of that, I mentioned that the source task is going to be called with the poll method. That's going to get a list of records. And this has to turn those API responses it got from the Xbox API into what's called a source record, something that's generic to Kafka Connect. I'll come back to that in a moment. Actually, no, let's do this now. So you give everything back to Kafka Connect in a standard format called a source record. A source record is made up of a few bits and pieces. Firstly, the name of the topic that you want the message to go to. And that's, if you think my connector is delivering messages to the achievements topic and the presence topic. So each source record I give it has to say, this is where this event is going to. So that is in here. When I create a new source record, the third argument is the topic name, and I'm getting the topic name based on what kind of Java Pojo I'm giving back. I need the message itself, so obviously here's the connect record to be put onto the topic. This is a really useful bit. You tell it, you give it a little bit of metadata telling it what Kafka Connect calls the offset. You do this so that the offset is going to depend on what your backend system actually is. You're sort of saying when this data came from. So if this was like a database table sort of thing, it might be a row ID. For my purposes, timestamp is the most useful thing. So you can see here I'm creating my offset, and I'm using the date time from that particular achievement or that particular online-offline event. And the reason, and when you do that, Kafka Connect will deliver the message to the actual topic, but it squirrels away that offset that you've given it and puts it on a separate topic called offsets topic. So even if Kafka Connect crashes and has to restart, it's persisted, it's safe on a topic. At startup, it knows where to go and get that. And the reason it does that is so when your connector starts up, it goes to that offsets topic and then delivers to your connector. Here was the last message you sent me. The last message you gave me, the last message I delivered to Kafka, you told me had an offset of blah. And whatever the offset is up to you as the developer of the connector. It can be a primitive, it can be a string, it can be an int, but it can actually be an object. So like if you're doing a database connector, you might have database name and table name and row ID or something like that. I mean, the offset is going to be given to you at startup, so it's kind of up to you how you interpret it. But the reason you do that is because when Connect starts, I don't want to go back and get every achievement, because the REST API that OpenXBL gives me will give me the last 50 achievements. It doesn't know that I've already sent 49 of them to the Kafka topic. So by keeping a timestamp safe, being given that when I start up, it means when I poll, I can filter out all the ones that are older than that timestamp, so I don't deliver any duplicates. So in other words, Kafka Connect makes it really easy for me to avoid producing duplicates. It lets me manage all the state safely on a Kafka topic without me having to implement any of that in my code. It's sort of a standard thing for Connect. So in my source task, you're given this object in the superclass called context, and its context has an offset storage reader that will get you the latest offset. And the offset can be different for each different topic. So in other words, the offset of what was the last achievement I sent could be different to the timestamp for the last presence online-offline event that I sent. So it's smart enough to know that the offset is specific to whichever topic we're talking about. And that is kind of everything you need to know for writing a connector. I've sort of skipped, that is just this bit. I mentioned that you could do transformations. I haven't got time to get in that today, but if you want to make tweaks to the data that's coming out of the backend system before it hits the Kafka topic, you can. So a common thing of that is if there's some like sensitive PII data in that external system and you don't want that on the Kafka topic, here's your chance to filter it out before it ever hits Kafka. Those kinds of, and you can make like formatting change. Maybe if the timestamp is in a different format and you like it in some other format in your Kafka topics, you can do those kinds of casts and changes there. And then converters, for today, I'm using a JSON converter because JSON shows up nicely in screenshots, but you could use another format if you liked. And I remembered to hide my API key. Good. So that's Connect. Really, so quickly to wrap up on Connect, it's quite smart. It's a distributed system. You can run multiple worker nodes, and it will, if you give it, you ask it, it's got a REST API, so you ask it to run a connector. It will distribute them across the worker nodes. If one of the nodes dies, it will move that to a different node and restart it. It manages state for you, and all you have to write is that source connector class and the source task class. And it will call you on poll, and you do whatever you need to do for where your data is coming from, and you deliver it. And the only reason that that project is as big as it is because I've added in that timer queuing sort of stuff just so I didn't spam Xbox too much. So now we've got those two topics with Kafka events. Now we want to do something with them. So that Apache Kafka's answer to that is called Kafka Streams. Again, it's a Java library. This one isn't like a hosted runtime sort of thing. Kafka Connect is like an application that runs, and then you give it jars with your connectors. Kafka Streams is just an API, like a jar, a lib that you run in your own application. I got this off the Apache web. No, this was from a colleague of mine, actually. It's pretty. What it's doing is it's letting you process the events while they're in flight. You can do stateful processing. You can do exactly once processing. It's similar to Kafka Connect. It gives you ways of managing your state to make sure you don't reprocess events you've previously processed. I'll start with a really, really simple example, and then I'll show you the Xbox one. So imagine you've got this topic with this stream of events. The blue text is like the key for the message, and the dark text is the actual message contents, and we're sort of going this way. So what you get with Kafka Streams is a Java DSL for doing processing events in a streaming way. So what I've got here is taking in a stream from that topic and filtering out everything with the key of bingo. So that's those two. and then I'm mapping, everything is key value, so I get a key value in. I'm leaving the key as is, but the value I'm making uppercase. And then I'm writing that to a new Kafka topic called my output. So what I get is a topic like this. Only the bingo messages, and I've changed the text to be uppercase. So this is the kind of code you're writing with Kafka Streams, and it manages stuff, like I say, about doing it exactly once, doing it scalably, keeping state for you. And it's got functions, it's got sort of stream processing functions that are quite high level, that can help you do stuff like aggregating over a window or summing and that sort of stuff. So again, for the purposes of this talk, I wrote a sample app that shows different things you can do in Kafka Streams, all using Xbox data. And I came up with, how many ideas did I come up with? Half a dozen? No, more than that. 7. I came up with 7 ideas of things I might want to do with Xbox data. Starting simple and getting a bit more interesting. So to start with, filtering. So I tried to come up with an idea of what events I might want to weed out. One thing I've noticed with OpenXBL is you call the achievements API for a list of the achievements from your friends, your Xbox friends. That sounds wrong, Xbox friends. And sometimes in the API response, you get achievements from complete randoms that you've never heard of. I mean, I'm sure Valino Rosa is a lovely person, but I don't know who they are. So this is an ideal, I mean, say ideal. I could have filtered this out in the connector, but I wanted something to do with Kafka Stream, so I left it in. So I want to filter this out. So how did I do that? Let me go back to... So what I have here is an example of each... Oh, no, wrong package. I've got an example of each type of processor that I'm going to be doing. So which one are we doing? This is the filter. So yes, I think I've already said this. Sometimes you get achievements from people you don't know. So this is an example of using streams to clean up that kind of noisy, dirty stream and turn it into a clean, ready-to-process stream. It's like pre-processing for your downstream analysis. So input topic is that Xbox achievements topic. My output topic I've called achievements.known users. Let me zoom in a little just so you can see. So what do I do? This is the interesting bit. I'll show you the bits that go into it in a moment. Firstly, say the input topic. And as said before, that everything is key and value. So the key for each message is the name of the person, and the actual value is the achievement. So that's like the Pojo schema site. So I'm filtering, and I've put that in a separate predicate, so I'll show you that in a sec. And this is optional. I'll show you why you might want to do this in a minute, but I've called this filtering step filter known users only, and then when I'm finished with it, it outputs it to an output topic. So all the clever stuff here is in this known users filter. And all this is doing is, known users is a predicate, so what happens is, you override this class, it's got test method, and then you return true or false. To avoid having to call the Xbox API too much, at startup, I call it once for my list of friends and get my list of friend IDs, and then I keep that in a string array, and I sort it so that I can do an efficient binary search. Every time I see an event hit the achievements topic, this is going to check to see, is that gamer tag in my array of people I know are a friend? It will return true or false, and then Kafka Streams will filter that out. So what I get as a result of that is this topic called known users, and then it's a subset of the events from the original topic that's just me and my friends. So this is kind of what working with Kafka Streams is like. You want to do something with events while they're in flight. You want to process your events in real time. And this code is a lot noisier than it really is, honest, because I've littered it with comments. In terms of actual lines of actual code, there isn't really much in there. Let's look at another example. Known users we've done. That's normal, playing Medieval Dynasty. Splitting. So sometimes you've got one topic with one stream of events, and there's like a mixture of things on there. So you want to branch it out into multiple topics of separate events. So that's a good streams use case. Let's actually use the code. Which one's this? Present splitter. That's this one. So the presence API in Xbox tells you when you're doing something in Xbox, and that can be playing a game. It could be using a media app, like watching something on Netflix. It could be in the dashboard or in the App Store or something like that. So I want to split that one topic out of the presence into 3 topics, a game and a media and an app one. So how do you do that? Nice and short. So I build a .stream, I take my input topic, I tell it what shape the data is on there. So at compile time, it checks all of this for me. So it checks that my filter is going to get one of this type of thing. So it's quite nice at doing compile time type checking, but then it's Java, so you'd expect that. I'm ignoring all the offline events because it doesn't make sense to be not, if you're offline, you're not playing a game and you're not watching a media app. So I'm only interested in the actually doing things. And then I call the split method, and then I call branch 3 times, and then 1 for if it's a game, 1 for if it's a media player, 1 for if it's an app. And then each one of these has got the 2 of which topic it's going to. So I do that, and what do I get? I get topics like this, xbox.presence.media, and that is me watching Apple TV. What was I watching? Ted Russo. It's really good. Enriching. This is where you've got an event and you want to add data to it from other sources. So the reason why you mightn't do that, the presence event looks like this. So hopefully you can see it, but it's got just a user ID, but it doesn't tell you the name of who that user is. So what I was thinking is if you were going to be processing these events downstream, you might want to know who that is, what their name is. So it will be helpful to enrich these events with additional information looked up about each user. So presence enricher does that. Where's that? This one. Have I said all of that? Yes, I have. Oh, and profile pic. I forgot. You could look up to see their smiling face and see what they look like in each event. As a general rule, though, this idea of enriching events to come up with a more useful payload is really, really common. So let's skip past the predicates and just look at the stream for a minute. So again, builder.stream, take the input topic, tell it the data type. Filtering out the presence topic is a little bit noisy, so I'm filtering out things that come out of sequence. Because Xbox tells you about your presence on different platforms, so like Xbox 360 versus Xbox One or whatever, if you start playing Xbox One, there'll be an event about playing that, and then when you stop playing that, it tells you that it gives you the timestamp and the event for the last time you were playing Xbox 360. So I'm filtering out of-sequence events and noisy events there just to make this less gibberishy. The interesting bit, the actual enriching, is this bit here. So it's a map. So I give it an event in, and I spit out an output of a slightly different shape. And you can see here, because all of this compile time type checking, that's the type without the extra data, that's the type with the extra data. And an enriched presence is a presence with a username and a profile pic and all of that. And it's this thing that does it. So again, it's a Java class called keyValueMapper, and it has one method you need to override, which is apply. It gives you, in this case, a presence object. I look it up, and again, to avoid making too many API calls, at startup once, I look up all of my friends, put them in in-memory map, and then I can look them up and add them into the event that I then return there. So I get events like this. That was last night. I just started playing Unravel. Don't know if anyone's played it. It's really cute. You play a red ball of yarn called Yarny, and it's very, very sweet. But what you can see is it's the same event that was on the presence topic, but it's now got my gamer tag and my real name and my profile pic in the event as well. And again, just to not show every screenshot with an IBM UI, here's doing it in the command prompt. So I'm reading that enriched presence topic, and I get quite a lot of this topic is me playing games. One thing I've learned from getting this demo ready is I spend a lot more time playing games than my friends do. Matching. Actually, this is where we start getting interesting, because it's not just about processing events in isolation. It's interesting to try and process an event in the context of events that have come before and after it. So for this, I've mentioned this presence topic, where every time I start playing something, there's an event. When I stop playing something, I get an event that says offline. But what would be, and here's an offline example, so that's when I stopped playing. That was last night as well. In fact, that was when I finished playing Unravel. What's useful is to be able to recognize, pair those start and stops together, and then emit an event that I've called a play session of, he played this from this time to this time. Because that's the kind of downstream event that is going to be easier to analyze and do stuff with. So for that, I made play session generator. Where did I put that? What's it doing? Pairing start and stop events to create a play session. Oh, and I had to do a little bit clever stuff because some of my friends annoyingly go straight from one game to another. They don't go offline in between. That broke my code for the first version of it. Like, who jumps straight from one game to another? What? Just no. But now it's smart enough to handle that. So what's it doing? This is where we start using some of the cool bits of Kafka streams. You build a state store, and under the covers, it's storing these on topics. So if your app restarts, it can restore all of the state of what it's seen so far. You know, what was the last, because it's keeping track of, I've seen Dale has started playing this, and he hasn't finished yet. That's an active in-progress play session. So you can keep that safe without needing to implement any storage yourself. A quick predicate just to filter out things that aren't games, because I was only interested in play sessions being about games, because some of my friends just use their Xbox as a Netflix box, and they were making my topics all noisy with Netflix rubbish every day. So what we're doing, again, same as all the ones I've shown you so far, builder.stream, take the input topic, tell it the data type. And then now we're doing a process. Presence process supplier, I've imaginatively called it. Given it a friendly name, I'll show you why in a minute. And then I'm filtering out, I do the pairing start and stop before I filter out the Netflix, because otherwise it would screw up my ability to recognize starts and stops if I only filtered out the Netflix start events. So yeah, I do it in that order on purpose. And then I output to the play session topic. So this one is a bit complicated, so I'm not going to go through this in detail. But essentially, I have this state store that is created for me that I've called open sessions, and it's basically all the people that I've seen, all the events that I've seen someone started playing a game, and I haven't yet seen them stop playing a game. So then every time I get a new message on the topic, the presence topic, I look to see, key is their username, their gamer tag. I look to see, have I got a session for them already? Nope. In that case, I'm starting a new one. If I have, it kind of depends on, are they jumping to a new game or are they stopping? So I create a pair, and then when I'm at the end of this, context.forward is when you've recognized something you want to emit, you call context.forward. And it's not a return, because this lets you emit multiple things. Like you might want to emit 5, 6, 7 events for something you've just seen, so you can call context.forward as many times as you want. But the point is, you are called every time, your process method is going to get called every time there's a new event. You get given somewhere to keep stateful stuff in that is handled for you across a restart. And then when you've recognized something that looks interesting, like I've recognized a start and a stop, you emit that with a context forward. So I really like this. This is the kind of thing that's super useful. So what do I get? Oh, I'm going to have to pick on Andy for playing Fortnite again. So instead of getting offline and events, you just get this. And I forgot to show you, I also did some stuff like, now that I've got the event from the start time and the offline time, I can do things like work out the duration. So I can tell you how long he was playing Fortnite for. Actually, the amount of time I spend playing Call of Duty, I should not be throwing this particular rock. Counting. You can count how many times you've seen something happen in a stream of events. That's quite useful. So what did I think of for this? Counting how many different games people have played, because I've noticed that some of my friends just, like you could, I was going to say glue the disk drive shut, but hardly any of them have got actual physical media nowadays. They just play the same game all the time, whereas I signed up to Game Pass, and I'm going to get every last pence worth out of my Game Pass subscription. I'm going to play every game I think of. And actually, you helped me find a new one, so thank you. So what this is going to do is keep a running count of how many unique, distinct games each of one of my friends has played. And it's going to emit that. So every time they play a game they've never played before, an event will be emitted to the Xbox Games Counts topic with a new number. So how did I do that? This one's getting a little bit longer. Filtering out ones without game titles. Again, Xbox Live API is properly noisy and returns some gibberish. So I can't count games if I get an event that they were playing something without a title, without an ID. So filter out the noise. Group it by the gamer. One thing I really briefly mentioned at the start is Kafka streams can make it easy for you to distribute your app across multiple worker nodes. So what you want to do is make sure that each processor is going to have all of the events for a certain player. Otherwise, if you distribute the counting and one's counting some and one's counting the rest, that's going to screw up. But you can distribute it so you can have all of the events relating to me go to one place. So that's what that group is doing. And then once you've grouped them, you could do an aggregate. So an aggregate needs three things. A method that will be called to start a new count, a method that will be called to update the count, and then a method for outputting the results of the count. Kind of obvious. That was R2D2, sorry. So yeah, it's kind of obvious, like that's how you count things, but so what's the init count doing? It's just creating a new object, and player games is basically a list of all the distinct games each player has played. So it's that's fairly simple. What's the update count doing? It's looking to see, it looks in that map, has he already played that game? If he has, we don't need to add it. And then finally, we just take the size of that object for emitting. So that's those three things. Init count, create a new map. Update count, check if it's in the map, and if it isn't, add it. And then the materialized will just return the count of how many things are in that map. And then we output that to an output topic, which I called game counts. So what you end up with is a topic like this. So like I say, you can see, I took this screenshot a few days ago, and I've played a few more games since then. I'm up to 37. Andy just plays Fortnite. There's a few other, Jordan is another one who only plays a few games. But yeah, this I found really interesting, that you can spot the people on Game Pass, because we play way more games than anyone else. And that's just how many I played since I started building this demo for this talk. And again, you don't have to use a particular UI to do this. So if you use the console consumer, you do have to use slightly different config, because this isn't returning JSON anymore. So I'm just using an integer deserializer. I could have wrapped it in a JSON payload, but for some reason, I just output it as a number. Last couple of examples. Summing. So similar to keeping a running count, you can sum how many times something has happened. So achievements in Xbox come with a gamer score, depending on how rare and how difficult that achievement was to get. So this one, this was from a couple of days ago from Unravel. I only got a lowly 20 points for that. But what I thought, because I'm far too competitive, I thought I could use Kafka streams to work out who has earned the most points from achievements in any given period. And I arbitrarily picked a week for this. Oh, no, you're looking at a screenshot again. Let's go back to here. Where's weekly score counter? This one. So yeah, this is going to, every time an event hits the achievements topic, it's going to increment a running count for that player. But it's going to do it over a 7-day window. So it's not the total score they've ever had. It's going to look at, and for all the events in the last 7 days, how many achievement points have you earned? And that's actually kind of useful to be able to, when I do non-silly work with Kafka, imagine like I'm trying to anonymize customers that I've worked with recently. Imagine like a production line where they want to see how many things they've produced in the last week, or how many things they've produced in the last day, and have a topic that just has that running count of, in the last 24 hours, this is how many things widgets we've produced. So that idea of producing that live stream of counts is super useful. So what does this look like? Again, builder.stream, you take the input topic. I'm mapping it, so this map is basically taking in an achievement and outputting the int of what the gamer score was. So you can probably guess what that looks like, but I'll show you anyway. It's outputting key value pair. The key is still the user ID, and the value is the score they got for that achievement. Nice and simple. So now we've mapped it, we group it. like I said, you group it so that if the processing gets distributed, you keep all of the processing for a certain user in one place. Window it over a 7-day period, so that's windowed by, nice and simple. And then essentially this is doing map reduce. So I did the map to turn it into a score. Now I do the reduce, and you don't have to write that because, I mean, if you want to write a custom reducer, you can, but all I want to do is sum, so I can use the built-in, and then turn that back into a stream and output it to a topic. And here I'm doing one final map to turn it back into a JSON payload. So what I get from that is this gamer score topic. And you can see that, when did I take the screenshot? I took it last night. 805 points this week. If you're not an expert, that's good. You should be impressed by that. That means I spend far too much time playing games. At least that's what people tell me. And here's where the problem is, a new event is emitted to this topic every time a person's players change, so there's quite a lot of me. One thing you can do with Kafka, if you only want to keep the most recent score for each individual, you can turn on a feature in Kafka called compacted topic. And what that means is when it sees a new event with a certain key, it will dump all the old messages with that same key. So if I didn't want the history of my score before, if I just wanted to keep the current week's score, turn on compaction and all those go away. So it's kind of up to you if you want that history, if that's useful to you or not. Last one, I think, tracking. So by tracking, what I mean is I had this topic for play sessions. For someone has been playing this game from this time to this time, and I was curious to see who of my friends spends the longest playing games. So I wanted to keep that duration field I showed you. That's the start and the difference between the start and the end for a play session. I wanted to see which of us had the longest play session. Spoilers, it was me, because never mind. So how did I do that? Builder.stream, taking the input topic. The input topic for this was that play sessions topic I was showing you before. Groups it by key, so I keep all the process. Anytime you're doing something stateful, you want to keep all the related events in one place. And then it's another aggregate. So I give it an init to set up a new longest play session, 0. This one, which will basically just do a comparison of, is this longer than the last one? So this, actually, let's zoom out so you can see. What this will get called with, the aggregator, you'll get called with apply with what's the new event that's come in, and what was the one you stored last time. So all I have to do is compare the duration, and if it's bigger, I'm going to return the new one. If it's not bigger, I'll give it back the one it gave me before. And then Kafka Streams will handle keeping that safe and managing that for me. So all I have to do is implement the logic of what makes, how to do the aggregate. And for this, simple comparison. And then I take the output, and I emit it to a topic that I called playsessions.longest. And like I say, unsurprisingly, actually, this is me trying to pretend it's not me who clearly has the longest. He's just dropped off the bottom there, but yeah, that was Andy's longest playing. For me, it was a Call of Duty game from January, and it was like 4 hours or something. It's not good. So that was kind of my whistle-stop tour of Kafka Streams. This is not everything it can do. This was just the kinds of things I could think of as a first intro. What I wanted to show you is that you can do processing of the events on the Kafka topic using the tools you get with Apache Kafka. And if you're a Java programmer, this stuff is really simple. One last thing I want to show you. I mentioned a couple of times that it's a good idea to name each of your steps. It's optional, you don't have to, but you can give friendly human-readable names to every step in your stream processing. And I did that in all of these things, and I gave it a unique, where's my stream? There, like this. And the reason I did that is because there's a nice method in Kafka Streams. After you set up, so what you do when you're building your app, this is like my static void main. This is my entry point. So what I did here is I create a new streams builder. That's sort of the out-of-the-box Kafka Streams thing. Each of these are the classes I've just shown you. So I give it the builder, so it's adding the stream to this single streams builder. And then when I've added all the streams I want it to do, I call builder.build. And what I get back is a topology that I can run in the Kafka Streams app. But topology's got a nice method called describe, where it gives you like an ASCII art representation of your stream application. and this is from the log of my app. So this is a nice start. So I can see each of the different streams I've done, and you can see how under the covers, Kafka Streams has broken up that high-level Java into many more steps that I didn't have to worry about or think about. And this is useful for debugging. Like, I always have this output to the log at the start of my apps. But one thing that a guy did that was really cool, and his URL is in my slide. Where is it? That ZZ85 GitHub IO. He wrote a visualizer that when you copy paste this topology ASCII art into his website, and he generates you this really cool diagram. And I love this. Let me zoom in a bit. So what you can see is, like, I read from the achievements topic, and I filter out only the known users, and that goes to the known users topic. And then I had another stream that is getting all the gamers by the key tag, and then that's writing it to an intermediate topic, because like I say, anytime you're doing anything stateful, it goes onto there. So I can see all the different places and how some topics are the inputs for others and so on. As a way of debugging, it's awesome, but also I just find it really cool to look at. So that's a nice thing to go with. Anyway, I've just noticed that I've run out of time, so I'm very, very sorry. I'm terrible at time management. Hopefully, that was an interesting intro to Kafka. Hopefully, you've realized that Kafka is more than just topics and brokers, and it comes with all sorts of cool tools. Everything I've been showing you is on GitHub. If it helps you get started, I'll let you go get some lunch now. Thank you.